عبد الرزاق بطير تفضل. ربع ساعة.
السلام عليكم.
السلام.
أتأمل إنكم ما زقتونيش بس بوعدكم على آخر برزنتيشن لي بهذا المؤتمر. My presentation will be on utilizing local industrial waste and natural clays to develop green construction products in Palestine. This work was done here at Al-Quds University, and we used local industrial byproducts and clays to demonstrate a question that was asked this morning. Can we use some of the technologies and research that was done abroad to develop products here in our country? And if you were here this morning, I answered yes. And I have to acknowledge my co-authors, Dr. Ra'id معالي and Dr. Omar Surhi, who are both from Al-Quds University, although I am now from Birzeit University. Yesterday we saw a lot about sustainability, and I emphasized this morning how important sustainability is, especially for a country with very limited resources, very limited sovereignty, very limited control, and very limited economy. So for us, sustainability is not just a necessity, it must be a must. It must be at the top of the agenda of every engineer and everybody in this country. And yesterday, Professor Imad gave some definitions of sustainability, and I will repeat them due to their importance, because I don't think here we emphasize sustainability enough. It's the ability of humanity or ourselves to ensure that the needs of the present are met without compromising the needs of the future or the future generations. It's also the preservation of the productive capacity of Earth in the foreseeable future, whether it be biophysical, in terms of biological, or physical resources that are on Earth. And we need to reach a dynamic harmony between the social, economic, and environmental, so that we can live in a clean, plentiful environment that will support us and support future generations. Now, as we all know, construction in Palestine and many countries in the region is the biggest industry that is there. We import, as Palestinians, all of our cement, and mostly from the Israeli factory. We also import most of our sand, and it's only coarse aggregate and water, which is not really freely available, that are locally produced. There are stone and marble dust is the second biggest, I think, industry, and generates huge amounts of revenues to Palestinian society. There are over 1,000 firms working in stone and marble industries in Palestine. This number can look attractive. Unfortunately, most of these are small and small scale. And if we use the Italian or Spanish or Turkish system, where they have huge factories in remote areas with very clean production and systematic processes, then we can have better results, but we don't. We also have quarries that produce aggregates and some fines. The maximum production of stone in this country is 350 million square meters. This does not mean we can produce that much, because we don't have the infrastructure to do that. And as I said, the annual turnover is quite huge, $500 million. The stone industry in Palestine is unsustainable, because we have very little control over our areas, because pollution is high, health and safety is neglected, Israeli closures, checkpoints, and limited access to many sites in Area C also make it more difficult to actually build factories. That's why a lot of the factories would be in areas A, because they are built up areas, and the Israelis don't really care. We have also very limited access to international markets. We come to recycling in Palestine. It's another sad story because we don't really recycle. We were talking this morning about solid waste recycling of 80% in some European countries. It's not actually 80%, it's almost 100% in many European countries. Almost 100%. And here in Palestine, we are excellent at recycling metals because they have very high values. Sometimes we don't wait for them to be recycled. We actually take them from the street and use them as scrap, which is unfortunate. Solid waste is starting to be looked at mainly because there is huge funding from donor countries. And I hope we as a country use these resources in novel and clever ways rather than just set up huge groups or huge bureaucratic systems and end up achieving very little and wasting all this donor money. Construction waste recycling is non-existent. Despite the fact that we have limited resources, we don't recycle construction waste. And I used the example this morning with the fact that in Holland, they recycle 100% of their construction waste. In the UK, in 20 years, they moved from recycling 10% to recycling almost 90% of construction waste. So it can be done. It has economic benefits, but it needs the encouragement. The main materials used in the test program that we conducted at Al-Quds University were Portland cement, lime, Cowlin clay, which is locally available, stone cutting dust waste, which is marble dust in the presentation I made this morning, and fine crushed aggregate, which is a byproduct of quarrying or crushing aggregates for concrete. As you all know, cement is a high pollutant. It also has a high value. Lime, on the other hand, although it does pollute, because we produce it at 300 degrees, its effects on the environment are much less. And if anybody here remembers the lime factories that our great-grandfathers and great-grandfathers used to have, we actually used to produce lime locally. The places used to be called Latun. And some of these are still in some villages here in Palestine. So we use these, and we carried a number of tests. We looked at two properties. It was just a demonstration to show that we can produce products, construction products, from these wastes. And we looked at two most important properties that are measured: the tensile strength and the compressive strength. And for the tensile splitting strength, we used 50mm cylinders, 50mm diameter cylinders which are 100mm in length, and we used cubes that are 60mm in size. All the tests were carried at 7 days, because if we talk about construction products, you don't want to wait for 28 days or longer. You want the product to be ready for use or for transport at a much shorter time. The table here, again apologies because I could not split it, so I put it as a whole, shows the different properties. We have crushed aggregate, we have Cowlin clay, marble dust, cement, lime, and we looked at the different sizes where we measured the samples, and we look here at the maximum load. Now, as with every testing, some of these samples performed reasonably, some of them showed immediately in the mixes that they will not work. And that's the idea of proving a concept or doing a demonstration, so that you can then select the few mixes that give reasonable results and then take them further in the research. Here are the main samples that we concentrated on, and they had again crushed aggregate, Cowlin clay, marble dust, cement, and lime. And we varied the percentage of cement from 30% to 10%, which is quite a huge saving if you can reduce the cement content to 10%, both environmental and in cost. You can see here that the figures for the splitting test and the samples with the highest cement, of course, performed very well and gave very high values. But if you look at the samples number 3, number 5, and the last one, it shows that they achieved reasonable strength, because in blocks you don't need very high strength. A 2 Newton block, 2 Newton per millimeter block can give you results. So if one works more on this, we can actually achieve a reasonable product. The splitting test results showed also similar trends, although the second sample, as you can see, where we replaced some of the lime with the cement, where we use a combination of lime and cement, it gave actually results which are slightly bit better than the first one. Now, you might not think that's very important, but the splitting test is actually a good indicator for durability, because if the sample does not crack, it means it can last longer and it's a more durable and also easier to handle. More tests, and as you can see, the results in terms of strength, Newton per millimeters, are rather low, but as a start, they are promising, because if you can reach 0.5 Newton per millimeter, it's a good start. Splitting tensiles are, again, the second and third mixes, where we're using lime and cement at different ratios of 20 and 10 and so on, are giving us reasonable results. This is the splitting tensile, where 2 samples, where we had 100% lime as a binder, we did not use any cement. 2 did not perform at all, and the third one showed us a reasonable result, although 0.25 is rather low. With 50-50 binder between cement and cement and lime, you can see that we did not really lose much strength in terms of the tensile strength between the first and second columns you have here. The compressive strength of the different mixes, as you can see from the figures, we don't need even to specify that we can actually do or choose some of the mixes number 1, this one, and even the last one are giving us reasonable compressive strength compared to our control, which has 100% cement, and we can achieve a greener product using waste. In conclusions, construction waste used in this study has potential to be used to replace virgin materials and produce blocks and bricks for use in construction, whether they're used for paving or used for building. Blocks can be produced with acceptable uniformity. We measured the uniformity. Reasonable standards for handling using up to 50% kaolin clay. The kaolin clay is an available clay in Palestine, and it can be used with the much reduced quantities of cement and lime. Kaolin clay and fine aggregates are available almost everywhere in Palestine, because we have quarries in every city, almost in every localities. And to conclude, further research is needed to optimize the main mix ratios, and most importantly, these are very short-term tests. In order to be satisfied that these materials can be used, we need to look at durability tests to see the stability and integrity of the product is maintained over a long period. I would like to acknowledge that this work was done by 3 final year students for their graduation products. Unfortunately, they're not here. Luckily for them, they're working overseas mostly. Thank you very much, and I'm happy to answer any questions.
شكرا دكتور عبد الرزاق، بيرفكت تايمينج. بنستكمل الان الاسئله بناخذها بعدين دكتور عبد الرزاق. شكرا. الآن ناخذ المحاضرة الثالثة. دكتور عبد الحليم خضر راح يعطينا talk about use of relevance vector machine for groundwater quality monitoring network design under uncertainty. والعنوان معقد شوي بس الدكتور راح يحاول يبسطه قدر الإمكان. تفضل دكتور الحليم. دكتور عبد الحليم خضر حصل على بكالوريوس الهندسة المدنية من جامعة النجاح سنة 2004. ماجستير في هندسة المياه والبيئة من جامعة النجاح عام 2007، ودكتوراه في هندسة المياه والبيئة من جامعة يوتا الحكومية الولايات المتحدة الأمريكية عام 2012، وهو حاليا أستاذ مساعد في جامعة النجاح الوطنية في قسم الهندسة المدنية. تفضل دكتور عبد الحليم.
السلام عليكم. Good morning everyone, and thank you for coming to my presentation. Today I will speak about my work on the use of a relevance vector machine for groundwater quality monitoring network design under uncertainty. My co-author is Dr. Matt McKee from Utah State University in the United States. First, I will talk about some background and problem definition. Then I'll present the study area and conceptual framework. Then I'll present the results, conclusions, and recommendations for future work. So we all know that groundwater is important, and it's actually the only source for fresh water in many parts throughout the world, and especially here in Palestine. But this precious resource is being jeopardized through anthropogenic sources of pollution, such as industrial, agricultural, and municipal sources,